So this is what is time now in
It
India?
is your talk is from 10:30. It is now 10:08.
20 minutes
You
more.
can take few question. Yes.
I see. Um, so in half an hour time, or what is the
Yes,
plan?
20 minutes time. The students are free to interact directly to Professor Buyya.
Okay. But I also have one more keynote talk. I think today is too many things. Looks like.
Okay, so I think they are not free as of now. So better we'll start the talk. After that, they will be free.
Yeah,
Yes.
it will be in the same link,
So
sir. After,
can we prepone? Can we prepone the talk, Dr. Bharat?
I think we can prepone, sir. We can start.
Yes, yes.
Let
So
us
it will continue
yeah,
this
let
session.
us let us formally end the inaugural session.
Yes.
And, yeah, on behalf of the organizing committee of ICICC 2021, I would like to extend our deepest thanks to Professor P.K. Nanda sir, who encouraged us for continue this uh, conference. And beautifully, he also introduced Sikha Anusandhan University and the effort of the university towards the conference and the research activity in the university. Okay, thank you, sir, for giving your valuable time. With this, also, I would like to thank Professor Rajkumar Buyya, sir, for introducing importance of cloud computing and encouraging us. And I also like to thank distinguished Professor Bhavani Sinha, Professor Samarjit Bora for attending this inaugural session and motivating us. And I would like to thank Professor Sikant Patnaik for nicely introducing the guest and carrying out this inaugural ceremony. So thank you everyone for joining the inaugural session. So we are starting the keynote session. Uh, Professor Buyya, I will stop presenting. You can share your presentation and we can start.
Yeah, sure. No problem. Oh. So it says can't share your screen. You must grant permission. I think I pressed something. I'll just log out and log in so that it gets.
Because it's clearly visible now. You are muted, sir. Please unmute.
Okay. So now you see you can hear me?
Yes, yes, we can hear you. The
Yeah.
screen also.
And you see
visible.
only one screen. You see only one
Yes.
screen, right? Only one.
Yes, yes, sir. Yes, perfect.
Okay, not like one small, one big one, nothing, correct?
This full screen. Yes.
Yeah. Okay, no problem. So thank you very much for inviting me to be part of this conference and to present keynote talk. I think it looks like today is my busy day in terms of delivering keynote talks. Today morning, there was a conference in Washington, the US, where I participated and I gave a keynote talk morning 7 to 8 o'clock. Then, of course, now another one. I thought I was probably doing today part of the inauguration, but anyway, good to know that you reminded me that I also to present keynote. Then from another 1.5 hour time, I have another one keynote talk in conference that is being held in Mathura. So they are starting at 2 o'clock. So good that we have got the time in between. So thanks again for inviting. So great to see many of you. And today I will discuss about some of the recent advances in cloud-based computing for big data and IoT application. I think high level I did mention during my that opening remarks, but I will show with more detail now. So here is the outline. So very briefly, just show you the different computing paradigms, but we just take a look at cloud. Then we take a look at the today's applications of cloud and the architecture. Then we will take a look at the trends, the technology trends a bit more, and the application trend, and then see how that impact on the cloud architecture. After that, I will present about Aneka Cloud Application Platform, especially the latest version and the features of this Aneka latest version. Then we will take briefly look at the Internet of Things, then what kind of computing paradigm that we need to support IoT applications, what is called as edge and fog computing, we'll take a look at. But particularly, we will take a look at some of the software technology that we developed recently and their application to healthcare and even in the context of COVID-19 monitoring. Then conclude at the end. So this is the plan. As we all know, during the last 50 years, many advances have taken place in computing and communication. Look at computer architecture all the way from big mainstream scale computing towards what we call this cloud now, which has become a reality, where the computing is available as a utility service on a pay-as-you-go basis. So you don't need to really own a big computing capability. You can simply rent it and use it and pay for it to consume. That's what cloud is all about. Of course, in between advances, all of you are familiar with. Then moving towards furthering the input that comes to these applications is not just from humans entering data. It will come through sensors and actuators which can control the physical environment. So this integration of what is called a cyber physical system, the physical world and the cyber world integrated, which is Internet of Things computing paradigm, and that paradigm requires much more advances in cloud to support them. So which we will discuss more as we go along. And in terms of these advances, what are the key drivers? The major drivers for advances in the past used to be big scientific and military application, but now that is taken over by big population-oriented application. Anyone can participate and gain services, access services through their mobile devices or a IoT device they are wearing, like a watch, for example. Watch becomes a Internet of Things device. So watch can talk, watch can monitor your heartbeat data, or your ECG data. So such kind of application, the trend, both technology and application trend. So that is driven by big population. So that is the major push now. And when we take a look at cloud, essentially what we have at the one end, capabilities such as compute, network, application, we user subscribe to them and use it and pay for it to consume. And when you subscribe, it may seem like you subscribe to one provider, but actually harness the power from multiple providers and deliver response to end users. So this is the kind of architecture most cloud applications today are using. That means it is a geographically distributed, data centers and offer the cloud service. They're integrated to deliver applications and applications from many domains, including science and business domains. Many small and medium businesses are harnessing this power. What are more even popular are these what we call consumer application. So such as video conferencing software systems like Zoom running on a cloud, and Twitter micro-messaging service running on a cloud. Then storage, that is for example Dropbox as a cloud storage for sharing files among multiple people, which can be used as a backup. So this is also a cloud-based solution. So like this, there are many consumer domain applications are now on the cloud. In particular, so here are some list of applications that we regularly use, including this Facebook, YouTube. These are cloud-hosted applications supporting massive number of users, massive e-commerce. And during last 18 months, it is even more prominence gained with most of the commerce taking place. Of course, delivery physical, but the virtualized ordering. Then interaction between people through Facebook or Twitter. These are all applications running on cloud. So I think what I want to highlight is in a minute, you can see millions and millions of operations are happening which on an application that are running on cloud. So cloud success is already felt. So it has become a very ubiquitous one. And moving forward, why should we worry about further advances in cloud computing? So as conference name indicates, intelligent systems and cloud computing. So these intelligent systems need large scale analytics. Then only you can provide intelligent services. So and the advances in technology is actually pushing them further. So you see here are these major advances now. Are prominent technological advances like containers, what we call, this is moving from virtualization to microservices. So then networks, not just standard network, but becoming software defined, so that we can virtualize networks. Then we should be able to provide trustable services through blockchain-based integrated capabilities. Then of course managing clouds and managing large-scale data analytics and providing intelligence services, which is enabled through AI. AI, artificial intelligence, has become a very big thing these days. So now how can we create and advance cloud computing to support them? So that is something I like to highlight now on. Then of course COVID-19, all of you know the challenges the world has faced. But the good news is that the cloud computing has supported business operations and people interaction in spite of all of this, and the usage of cloud has really escalated, probably 50% more than what was happening in 2019. So this is a big thing. Then the application trends, just if you look at AI, so just to meet requirements of AI workload, there are vendors who developed processor, that CPU, processing element that are very much geared towards AI workloads like TPU, transaction processing units, and so on. You can see, so these are very much AI oriented. So that means it is not just developing a hardware, but we also need to develop software system that enables rapid creation of such application in a much more simplified manner with little effort. So that is the push towards productivity of software engineering. And so that is the one which impacts the architecture, not only infrastructure but also application. From that perspective, let us briefly take a look at how these impact this technology and the application make impact on the architecture. So here is a high-level view of cloud. But if you start going deeper, what you have is collection of servers that are interconnected. So now so they are software defined. So that means we're able to virtualize network, virtualize compute resources, then virtualize application services. So that is at the infrastructure level. Then of course at the top, users make a request to cloud, and users define whatever service requirement. Because here services are offered as a paid services, we need to make sure that the capabilities are managed in such a way that the services are offered to consumers as per the expectation that you agree to deliver. This is called service level agreement. Let's say a request is made and system accepted. For that, a virtual machine is created mapped to physical machine on which application is running. And with time, number of users can increase. When number of users increase, you need to be able to expand across multiple cloud. And when number of users decrease, you need to be able to shrink. So this ability to expand or shrink is called elastic property of cloud. And this elastic property is actually simple, but it is very how you manage it in how you realize it in real world. And by having a better realized elasticity, so we can provide cost-efficient services to end users and also reduce the consumption of energy of these cloud data centers. So that is in high level, how the system actually works. Now let's take a look at how this can be made possible. So here is one of our software technology called Aneka. Is a cloud application platform, and this platform is a software platform, comes with two key components: SDK, one software development kit, second one is runtime machinery. So this SDK has various APIs and tools that helps you to build application rapidly, such as thread model, task model, MapReduce. And then once you build, you can deploy in a private and public cloud. And of course, when you look at private and public cloud, regularly, there are numerous vendors are coming out with their own infrastructure interfaces. So therefore, we need to further advance this technology in such a way that we can easily support them. And then when we go deep inside this Aneka, so what it has is a container services, and these services can be extended to support different application models. Like for example, this way AI is becoming very popular. So the existing way of expressing this application may be too complex. So therefore, how can we create some new model of programming that we can use for your application and you can quickly implement in Aneka? And that means when you implement such a new model, you also need to implement scheduling algorithm for it. So Aneka provides as an extensible engine, you can extend to meet those new needs. So Aneka provides those APIs interfaces that you can use. So this way you can easily deploy application on different cloud environment. And this Aneka actually rapidly evolved over a period of time, more recently supporting privacy aware. So these days you see there are lots of privacy concerns. How do you deploy medical data analytic application, keeping privacy constraint in mind? So that requires new advances in terms of in the way tasks are allocated, the way the applications are scheduled to ensure that privacy aware computation are done. Then now more push towards IoT and deep learning application. That also requires much more advances in this platform engine. So we have done all those for the latest version of Aneka. And then when we say we want to deploy these applications where we can harness multiple cloud service providers. You can see there are many providers like Microsoft is offering, IBM is offering, Amazon is offering, Google is offering. Then you can create your own, infrastructure-based private cloud using OpenStack. If you have so many of these and you write an application, do you need to make it work for each and every platform? No. So Aneka provides you these plugins that hides all these differences from application developer or the user. So this is what I want to highlight, that this multi-cloud computing, much more strongly supported in the latest version. And this Aneka has been used by many around the world. But today I will focus, actually illustrate distinct applications that are developed more recently. So here are some traditional one from China Railways for locomotive design. Then back home in India, ISRO application, and Washington State University on medical data analytics. Then, for example, ID Delhi on deep learning for object detection. Then, of course, on COVID-19 research data set challenge that provides lots of data sets and how do we process it. So let me present 2 or 3, but more in the context of healthcare. The first one is bit engineering, the rest are healthcare. So here is from the design from scenario, the various 10 design scenarios, and you want to analyze them and find out which is the most optimal and suitable one. And so this was taking something like 4 days on a 4-core server, and to overcome the time from 4 days to take 2 hours, they set up a private cloud lab a facility. Explorer, they're able to do this discovery within, for example, 2 hours. Now, if you say, I want to get this answer, not wait for 2 hours, but I want answer in 10 minutes, what do you do? So local resource, the edge, local private cloud takes 2 hours. So you can actually harness the capability, extra capability rent from public cloud. So within Aneka, you can say deadline is equal to 10 minutes and budget is equal to 200 rupees. Define deadline budget. The system on your behalf looks into marketplace of cloud services and leases, rents those suitable compute capability affordable to your budget limit. Then use them along with your local, for example, and get it done within that deadline of 10 minutes. So this is how the next generation systems would be, which is illustrated. And coming to healthcare, so here is the one that integrates, sensing of data through ECG sensors, and data say come to mobile phone and you process it on a cloud where analytics software like EC data analytics is running as a service on top of Aneka on public cloud like Amazon. So users come with different requirements. The system is able to allocate, manage allocation in elastic manner such that services are affordable and not spend too much of time delivering services. So this was demonstrated. This is a public demo, data captured through ECG, sent to mobile phone and run on a cloud, and results came back. You can see many interesting healthcare scenarios can be dealt here. That was healthcare. Coming to AI, artificial intelligence application, that is deep learning or machine learning. So here, like these days, many IoT or cameras with network access deployed everywhere. And so these video images that are coming in, and you want to detect what is the object, like in security, is there any suspicious subject of interest, or in cameras, or in the laboratory where you put these cameras, finding out how many computers are there, how many of them are used, what's happening. So this requires that real-time analytics using like deep learning libraries. So IIT Delhi, so researchers have created this cloud version of deep learning where they can do in a quickly and timely manner, not only harnessing the power of local but also remote resources. So we have research paper that describe. If you just search in our look or visit our website, you will find many detailed explanation of how this was realized. And coming to this COVID-19, during last 18 months, more than 200,000 papers are published. And you don't have time to go through all of them to find out what is the effective progress on vaccine, or which vaccine is better for which scenario, what is the risk factor. This kind of study, you need to go through so many papers. No one has the time. So to help that, we have built this machine learning based, algorithms that analyze this data on cloud and then give response in real time so that you can get quick response time answering these questions like progress in vaccine or risk factor and so on. And here is the simple results that shows when we do it on a single system, it took almost like 25 minutes, single server. The same thing we're able to do it on, say, multiple server like 4 or 5 within 3-4 minutes. So this way you can bring down innovation rapidly. So if you want in few seconds, of course, it needs to be harnessing power of multiple, many more servers in the cloud. So this is how Aneka, technology is advanced to meet needs of different application. As I said, right now Aneka 5.0, that's the latest version. You can download this Aneka from Microsoft.com. The evaluation copy available. Of course, there are many across the world have set up cloud lab and teaching and doing research in this area. And here are some of the Indian institutes across India, for example, even SO University last year. So we had very interesting session on hands-on experience on Aneka Cloud done by one of your staff member. I was hoping that there will be more practical things happening in the next conference. So hopefully it happened. And you can see there are labs used for research, innovation, and teaching as appropriate. So that was cloud-centric applications. Now let us take a look at, what if Internet of Things, that is when we say internet, primarily we mean networks of computers. But when we say internet of things, it is networks of everything. So your home become part of internet, fridge become part of internet, roads become part of internet, the temples become part of internet. All these places through different sensors and actuators. Sensors can be cameras, healthcare like ourselves, having a watch that can monitor our heartbeat data, having a sensor here. So this is the kind of one where such a approach leads to huge number of IoT objects deployed, something like several billions of objects. And it is projected that such an approach would have a huge economic impact because you will have a very smart services. And what are those smart world services? All the way from smart home to smart transport, then driverless car, the vehicles without driver. How can you drive? So it will have integration of IoT, sensing, mobility, and cloud. So there are many interesting applications that are coming up, which also mean that there is a need for advancing the technology, computing technology. And here is a picture that gives you a brief view of different computing paradigms. The very first one is a cloud-centric model for IoT application. That is the most dominant so far. And moving forward, so it is changed towards when you have a large number of IoT, the remote one unable to meet. So therefore, we can use the edge resources and deliver answers to users timely. But sometimes you may also have to combine capability from edge and the cloud together, and that is called as fog computing. So these are different models of computing to support IoT application. So this is conceptually. So now how do we build real systems, and how can application be engineered to achieve this? So in that regard, we developed a open source FogBus software. It's a framework for edge and for computing. It also incorporated with blockchain. That means when data is analyzed through a blockchain using FogBus, the blockchain integrated, if any tampering happen to the data, so you can say the result can't be trustable, so cannot be trusted. So that is the kind of achievement that is done. So here you see oximeter that captures the data, goes to the gateway machine, such as mobile phone, app running there, and send it to the edge broker. The edge broker has many edge workers, so which are running on tiny software hardware like Raspberry Pi. So then sometimes they need extra capability like Azure, public cloud. So and this FogBus broker is able to combine the capability from edge and cloud to deliver services to end users which are trustable. So this is a bit more, little more details. You can see this is the oximeter data capturing. The data is interconnected with the gatekeeper, health gatekeeper, running on an app, mobile app, and then running on a edge or cloud. For example, in case of sleep apnea analytics, is able to show severity of the disease. Is it mild? Is it emergency? Or is it normal? So where we are able to integrate different medical devices and the cloud edge. And this is also we demonstrated here in Melbourne University, like connecting that IoT device. Data is captured and data is analyzed on the cloud. And further, we advanced recently, microservices. I just mentioned that microservices are becoming important. So here is a content-based microservices environment, wherein each of these services are can be dynamically composed to provide very scalable services for IoT application. So you can, this FogBus is open source software. You can look at, you will be able to download from our website. And then, so these are practical work. And if you want those researchers who are, for example, may not have expertise or the time to build this practical system, practical infrastructure, practical IoT devices, practical application, these are all time consuming. And also, if you want to conduct some experiments in a repeatable manner, that is very difficult to do in a real environment. To overcome that limitation, we have developed a simulator. For cloud computing, we have Cloud Sim. for edge and fog computing, we've got iFoxim. So here is the open source simulator for fog edge computing environment, wherein you can simulate large number of IoT devices and the resources and user policies, and evaluate how good those policies are. So this is iFoxim, also open source, used by many researchers, worldwide for their purpose. And similarly, we further extended the basic iFoxim to include mobility. If you think of, say, autonomous vehicles as IoT, then these are moving and you're creating a smart autonomous vehicular services. So if you want to do such mulligan simulation, you need those migration modules. Then also if you have microservices. So all these capabilities available as a microservices, you need to be able to simulate them. So we added all those capabilities to the iFoxim and then create a new version called iFoxim 2. So this is another new technology, especially very useful for all the future generation smart services. This is my final example. Even early this year and also last year, due to lockdown, for example, in India, in places like Noida, Delhi, you have multi-story buildings and lockdown, people can't come out or not allowed to go to hospital, various restrictions. So this is where the drone connected with the thermal camera is able to go around that multi-story building, wherein people were asked to come to the balcony, and so this is able to go around and sense the temperature. If someone has a body temperature which is maybe seems like COVID-19 symptom, so you need to identify such a person quickly. So that data capturing, analyzing on the edge or a cloud are necessary. This is what we call drone-based network system for combating COVID-19 pandemic. So this is the work we did and published as well. So more detail, of course, this is a very rapidly moving target. So with this, let me conclude. There are several computing paradigms that promise this vision of how to make computing as utility, and cloud computing is the one which turned this vision into reality. So many exciting applications of cloud we saw briefly already. Then the way we can architect those applications, one can use appropriate vendor solutions, or also Aneka. We discussed more about Aneka's latest version, Aneka 5G, having special capabilities to support AI deep learning application, then deploy across multiple cloud. So this way we can minimize the cost of software engineering and minimize the time it takes to compute. So applications are already shown, and we saw a few of them briefly in our discussion. So this IoT is actually driving a lot of new innovation, but however, this IoT, there are two generations already. The first generation is cloud-centric IoT. The second generation is more of a edge and fog-centric. So with this edge and fog-centric, we can have benefits such as real-time services, then less load on the internet. So these other benefits. And if you want to learn more about more and more about this technology, advances in cloud. So we put together recently a manifesto for future generation cloud computing, wherein we identify many open challenges in this area and propose the direction. So this paper published in ASIM Computing Surveys. So you can download from my website. If you want to learn more about cloud computing, so certainly you can read, especially if you want to learn how to program cloud application using Aneka. So here is a book, Mastering Cloud Computing. So this is a bit expensive for primarily catering American market, something like $90. Now we have the same thing for Indian market, just for around $7-8, like 400 rupees or 500 rupees, depending on where you buy. So this is published by McGraw-Hill in India. Which has got Aneka programming discussed in depth, and we also have a same book for Chinese market for $3. So that book is Mandarin, the Chinese language. So most of the content of that book is in Chinese language, whereas the programs are still in English. Then of course IoT and edge computing also. This is a detailed book. These two. If you want to learn more, but you can see again during last 2 years, so much of advances happened in this area especially catering to healthcare and contact tracing application and so on. Okay, so with this, let me stop here. So I'd like to thank all of you for hearing patiently. And here I have provided you links to my university email ID and also Mandrasa email ID. So those of you who want to set up a lab, so you can contact me using Mandrasa email ID, and those who want to interact for research, so you can use my University of Melbourne email ID. So let me stop here. I think this will give you enough background. Hopefully, you can now ask questions and comments, and we can discuss. Thank you.
Thank you, Professor Buyya. Now it is open for question. Our student and teachers, those who want to interact, they may put forth their question either through chat box or through, say, microphone. Hello, participants, please. Bharat?
Sir, yes, sir, I have a question.
Yes.
Sir, using the cloud computing and using the edge computing, so it's like computing everywhere, and we are trying to include many IoT nodes and device-to-device communication. So everything is being connected, and on top of that, we need artificial intelligence algorithms to improve the task of each and every device, even each and every algorithms running inside a network node. So how is it going to affect global internet energy consumption?
Yes, so definitely internet energy consumption is increasing. So just this cloud data centers alone, the energy consumption of cloud data centers globally, worldwide, is actually more than India. The combined energy consumption of cloud data centers is more than India. Think of what is the kind of impact they have on the climate and so on. So therefore, there is a need for building better solutions, better hardware, better software, and better approach for cloud computing. Thereby, we can minimize that energy consumption. So this is one big challenge. Now coming to networks. Yes, networks are also play so important role. So, for example, even within cloud networks, so there, so it is possible that the resource usage sometimes goes to peak, sometimes reduces. At that time, the approaches such as turning off servers that are not used. Similarly, we can also turn off part of the network that is not used. So this requires for us to allocate resource in such a way that more and more compute and network usage can be freed up or turned off, and this is where SDN-based approach can play important role. So we need definitely more advances in how we organize, how we manage infrastructure, whether it is network or a compute, in such a way that this energy consumption can be minimized.
Thank you, sir. We have two questions.
Okay. Good morning, sir. Good morning, Srikant sir. Yes, sir. So this is Samarjit from Sikkim, Manipal. So, Rajkumar sir, what may be the security issues in fog computing from resource point of view?
Yes, actually, security is this broadly what is called privacy, trustability, security. Let's say broadly under security. So this under IoT, dealing with privacy is a big challenge, and then security is also a big challenge because if they're deployed so much ubiquitous everywhere, people can easily hack them or plant them with the wrong things, cause a lot of problem. Then especially the critical infrastructures are interconnected. That is a very danger. So for example, even the road networks are interconnected. Water distribution networks are interconnected. They can be operated from remotely. But these IoTs and all can be helpful also in that case. for example, in water distribution networks, if you have got all these toxic detectors, so if they send somewhere, then they can quickly block the movement of water from that place, for example, can be a good thing. But it introduces security challenges. Then if critical infrastructures like military and all installation setups have managed through this, I think it's a very big danger. The other one is attack on these services, like denial of service attacks, and can be a big issue in these environments. Yeah, therefore, these so-called various smart services, whether they're healthcare or transport or vehicular, even these vehicles, if really, let us say, autonomous vehicle comes into picture, correct? So autonomous vehicles are driving. So if there is an incident or accident, who is responsible, correct? So like who can take a responsibility? Should a minister take a responsibility? Should Modi take a responsibility for people, these vehicles running over farmers? Who should take responsibility? So if there's a autonomous, if they are AI driven, who will take responsibility? So security, privacy, and they're providing robust, resilient services, I think is going to be a big challenge as we go along.
Yes, it is always a green area to research, always a fertile area to research.
Yes. Yeah. So
Thank
when
you, sir. Thank you so much.
Yes.
So there are two questions in the chat.
Yeah, there are a few questions in the chat room. Okay, I see. Somebody's asking simulator for fog computing using based on Python. Oh, okay. So often people try to create their own Mickey Mouse simulator and use it. But here is our iFoxSim, which is actually developed in Java. You should be able to use it. The Java is also one of the popular languages. So somebody said, can we use Fogbus as a simulator? Fogbus is not a simulator. Fogbus is actually a practical system. Okay. So if you have let's say you are a researcher in scheduling, you can plug your scheduling to Fogbus and do experimental based research. You don't want to do experimental, you want to do thorough modeling and simulation, then use iFoxSim. Okay, because simulation is probably is generally discrete event simulation. Other is the experimental research. So then, what are the new research directions in for smart healthcare application? So if you think from healthcare application perspective, so like things like reliability, trustability, privacy, then also energy efficiency. So these IoT devices may not be connected to the electric power all the time. So maybe they're battery powered, or they may be even solar energy power. So how do we use their power very efficiently so that they're operational even nighttime and so on. So these are some of the challenges in edge and fog computing for smart healthcare. Then somebody is talking about encryption in cloud computing. Yes, these encryptions are used to provide, like for example, if you put data on a cloud, people are worried that, oh, somebody else will see my data. What do I do? Perhaps you can encrypt them and keep them. But what about computation? You may have to decrypt. No. So you can look into how to do computation and encryption, encrypted data. So these are, of course, if you do this kind of services like computation and encrypted data, so it introduces a lot of overhead on the cloud. But if you are concerned about security, yes, you should do it. Yeah. So that is other aspect that I can mention. And somebody will you please share a document or a work that implemented using iFoxSim? Yes, there are many. If you go to, say, for example, so just say, sharing a screen, just simply entire screen. Hello. So if you just go to, let's say, yeah, just type.
Sir, your audio is off. Professor,
by default, it looks like it's mutes when you enter again. Okay, thank you. You can hear me. Yes, you go to Okay, so to specifically answer so that question, let me share a screen. Hello. So they were just asking, can you share documents, the paper that are using IFOXIM? So you click here, let's say go to my website and click IFOXIM. You can see already 973 research papers are published by people that use IFOXIM for their various works. So here are many of those. You just click on, you can see somebody talks about QoS aware deployment aware application in the fog. They use IFOXIM. See, mobility aware application of scheduling in fog computing. So this uses IFOXIM. So there are so many. There are already, as I said, 970 papers, 973. So this year alone, 229. Last year, 269. So you can see thousands of papers are there. I mean, at least hundreds of papers are there. You can go through. Most of them, I'm sure, are easily, accessible. Those papers. Does it make sense? Yeah, just type IFOXIM. There are lots of papers that many researchers around the world have used it. Yeah, even so, just a few hours a train ride from Bhubaneswar to IIT Kharagpur. You go there. In IIT Kharagpur, there are many students who have used IFOXIM. Correct. So yeah. So I think it takes 4 or 5 hours, right, from Bhubaneswar to Kharagpur. Yeah, take a train, or you go by, it might take few days, but you will reach there. So talk to Professor Soumya Ghosh. So many of his students use IFOXIM and they have written papers and they can tell you more about it.
Any more questions?
If there is no question, then we must thank profusely to Professor Rajkumar Buyya for addressing, in spite of his busy schedule. So he has already talked, the delivery talk in the morning. This is afternoon. Then he has another schedule in the evening. So we'll not bother him much. Maybe if he is free, then we'll contact him tomorrow for an interaction. Thank you, sir. Thank you, and keep in touch. Whenever we are doing any international event, we will be requesting you to be with us. Thank you, sir.
Thank you very much.
Namaste.
Namaste.
Dr. Bharat, you can start the next event, Technophilia.
So the time we have provided
if
at
you
12.
need some break, or we'll start
Yeah,
Technophilia.
we need some break because the students might be busy. And
Okay, so maybe 15 minutes.
And everybody is requested also to join the keynote session 2 at 2 p.m. in the same link.
Yes, yes.
We can meet
So
at
all the
12.
audience, please join back at 2 p.m. for another talk from Marita M. Jablonska from University of Lodz, Poland.